All right. Hi, everybody. I'm Max Isensee. I'm one of the co-founders and CEO of Kitekraft, and we set out to build the wind turbine for the 21st century. It's a flying one, and we basically use software and drone tech instead of concrete and steel to bring down costs for wind power quite a lot by just using 5 to 10% of the material that would be used for a conventional wind turbine. So, the wind industry is wind energy in general. We love it, we want more of it, but the industry is struggling. So we have a lot of issues with setting up huge production facilities for these blades. You have supply chain issues. High interest rates for these projects are an issue. Low margins with very long lifetimes of the projects, and it only really works in the large scale. So smallest wind turbines right now starting at 2 megawatts, and then usually nobody builds a 2 megawatt single wind turbine. It's almost a park already. So that basically limits wind power only for the very large companies, utilities, project developers. And there's a gap in wind power that we want to address with our solution in the beginning before coming to megawatt-sized systems as well. So we can do better. Instead of having these large towers, huge blades, what we have is a very tiny tether connected to a ground station, and then the prototype that you actually see here, that's currently, it's a little bit mismatched because it's only a 2.4 meter wingspan kite, so that's just our prototype. But a similar system of the same power rating would be a wing of 20 meters. So that would be just a third of one of these blades of the wind turbine. Why does it make sense? I already mentioned the materials. We reduce it by 90 to 95%. So really just getting rid of the tower and these large blades. That leads to humongous cost reductions just for that, but also in the whole process of actually setting up a wind turbine. So from having a production facility to the logistics to setting it up and maintaining it, everything is basically easier if you have a smaller, lightweight system that you can access from the ground, everything. So our system just lands, so you can access and manage it. And you don't need specialized crews or heavy cranes and other equipment to actually maintain these types of systems. If you talk about the wind park setting, we're actually having a 3 times higher power density as well, because we don't have these huge wake effects that conventional wind turbines have. We have to take care of our tether length that our systems don't entangle, but that's quite easy to do. So yeah, with that, we want to make wind power much more accessible and viable for more locations than it is today. This is how it looks like close up. So on the right side, you have the prototype ground station. It's actually on a car trailer right now. It's connected via this tiny tether. It's just the size of a general electric cable that you have in your household, basically. And then the kite, which is a biplane aluminum wing, 8 rotors on it. And we use that as a drone to bring the system in the air. Once we are there, we fly in a pattern of figures of 8s. We'd love to show you a video, but we have a lot of them on our YouTube channel. And once we're flying in that figure of 8 pattern, we produce energy with these small rotors on the kite itself. So basically flying around mini wind turbines, but at a much higher speed than the ambient speed that conventional wind turbines see, and then transfer the power with the tether to the ground station, feed it into the grid, or use it on site depending on whatever the project is. So making wind energy half the cost and making it much faster and easier to deploy. That's our mission. We're starting small. So our first phase is with a 100 kilowatt product that we ideally want to build a pre-commercial demonstrator next year. That will be a first system that's suitable for powering energy-intensive farms. There could be microgrids, there could be industry sites and remote locations, growing to 500 kilowatt, and in the next step, going to the megawatt scale. Going directly to the megawatt scale does not really work because you usually want to have more traction, you need banks, you need insurers on your side to actually be able to deploy systems at that scale and build it at that scale. So that's what we do at the small scale, make it safe, make it reliable, and build that traction before going to large scale. For both of these phases, we have already customers in place with LOIs, and that's obviously what we want to do now. We also are preparing for our fundraise now. So it's a late seed round that we're targeting. Closing in October would be a goal, so happy to talk with anybody interested in this. And where are we at with this company? The most significant thing that happened just end of April this year airborne wind energy, so our technology, that space, is now part of the German EEG law, the Renewable Energies Act. So this gives us, like solar and wind power in the beginning, a guaranteed feed-in tariff. So it basically guarantees the takeoff of our energy where we want to build our systems in Germany. We also just got our operating permit by the German airspace authorities. This is under EU drone regulations, so this is easily applicable over the whole EASA, so basically the EU airspace. We have a fully functioning demonstrator and a grid-connected test site. At that test site, we also have a customer in place that will buy every kilowatt hour of energy that we produce there. And then I already mentioned the LOIs. We have a 4 million MOU, and yeah, that's Kitekraft. So happy to talk to everybody who's interested here, or a lot of you I already talked to. We're at the end of the sessions here. So yeah, thanks a lot.